Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not have this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 178. Please turn to page 178. I suppose I should do the same. Page 178, and this is problem number 183, the second problem on the page, 183. Here's how the problem goes. It says 7 pieces of rope have an average length of 68 centimeters. So we have 7 pieces of rope. We are told that the average of the 7 pieces is 64 centimeters. They go on to tell us that the median is 84 centimeters. They go on to tell us that the length of the longest piece of the rope is 14 centimeters more than 4 times the length of the shortest piece. And that's what we have here. The longest piece is 14 more than 4 times the shortest piece. 4 times the shortest piece plus a 14, that gives us the longest piece. In other words, L for the longest piece equals 4 times the shortest piece plus a 14 more. This equation is going to come in quite handy. We're going to need it in a while. The question simply is very simple, very straightforward question. What is the maximum possible length of the longest piece? As I always remind you, questions are always straightforward and simple. It is the answers that tend to get prickly. Here's the solution. If we want to maximize the length of the longest piece, if you want the longest piece to be as long as possible, then logic dictates that we must have the other 6 pieces as short as possible. We must minimize the length of the other 6 pieces. Let's list them, all the pieces, shall we? We're going to list them all. Here is our shortest piece, which is the first entry. Then we have the second entry, let's call it N2. Then we have our second and third entry, which is N3, third piece. The fourth piece is our median. The fourth piece is going to be our median because there are 7 of them, which means there are 4 to the right of it, 4 to the left of it, and these are arranged in order. And that's your 84. Then we have our N5. Then we have our N6. And then we have our longest piece. Very simple, very straightforward. The question simply is, if we want to minimize the length of the other 6 pieces, the question is, what is the minimum possible value that we can assign to N2 and N3? What is the minimum possible values that we can assign to N2 and N3? Can you tell me what is the shortest possible length that we can have N2 and N3? Can we have shortest possible distance that we can assign to the second piece and the third piece, since they are arranged in order here? What is the shortest possible? Can we assign a number for N2 that is something even lower than the shortest piece? Obviously not. Obviously not, because the shortest piece is so called because it's the shortest. So what length can we assign to it and still follow the rules of the games so that we don't violate any of the things that are told us? Well, here's the thing. If we can make the second piece just as short as the shortest piece, it will do the job. If we make the third piece as short as the shortest piece, that will do the job. That will do the job. I shouldn't have put a box around, a circle around it like this. I want to rewrite it. Here's your N2. Here's our N3. If we make N2 just as short as the first piece, if you make the third piece just as short as the first piece, it will still follow. It's just that we have the 3 pieces of the same length, but they are still You can pick any one of them, that's the shortest one. And then whatever the length is, this one is this guy, is this one, this guy, that's the smallest that we can assign the value to it. The second piece does not need to be longer necessarily than the first piece. These tags that we are assigning, the first, second and third, they're just arbitrary in this case. In this case they're arbitrary because we happen to have 3 pieces of the same length. And that's the minimum possible length that we can assign to second and third. Let's make a note here. So that's what this is, it's already written here. Now the question is, what is the minimum possible values that we can assign to n5 and n6? Think logically. What is the smallest value that we can assign to n5 and n6? The same exact logic will apply in this part, in the second half of the story. Can this n5 be 83? Why not? Because they are arranged in order. This is the median. Can it be 83.9? Can it be 83.99? No, it cannot be 83.99 because this is the median sitting in the middle. They are arranged in order. This has got to be at the least as same as this guy. Voila, that's the smallest possible value of n5 that we can have, the fifth piece, the length of the fifth piece. We can assign it to a value of 84 and everything will still be hunky-dory. And similarly, the sixth piece will also be 84. So those are our pieces. That's it. That's how we're going to cut the rope. We're going to have 3 pieces of the same length, which is going to be shorter than 84. We don't know how much shorter, we'll find out in a second. Then we'll cut a 4th piece, which is going to be 84 inches long. Then we're going to cut the 5th inch, which is going to be 84 inches long. We're going to cut the 6th piece, which is going to be 84 inches long. And the last piece we cut has to be such that it must be 14 more than 4 times the shortest piece. That's one condition we have to fulfill. The second condition that we must fulfill is that their average must be 68. There you go. That's it. We're done. Let's go for it. There are only 2 unknowns here. The 2 unknowns are the S, the length of the shortest piece, and the second unknown is the L, the length of the longest piece. We have 2 unknowns, we need 2 equations. Do we have 2 equations? Of course we do. The sum of all of these things must be 68 times 7, because there are 7 pieces. If there are 7 pieces and their average is 68, their sum must be 68 times 7. So that's our first equation. Oh, where is the second equation? Oh, right here. Voila, that's it. 2 equations, 2 unknown, 2 independent equations. There shouldn't be any problem solving it. Well, let's do it. Where should we do it? I need a room. I need a lot of room. So let's do it on the top, shall we? Let's do it on the top. Keep in mind, let's make a note here that the longest piece is 4 times the shortest piece plus a 14 more. Let's call this equation 1. Equation 2 is coming up. Equation 2 is going to arise from the fact that their average must be 68. So if we were to add them up, we get S plus S plus S, S plus S plus S, then we have 84, and then we have another 2 more 84s, 84 plus 84, and then we have our longest piece, and when we add them up, it must equal 7 times 68. Let's find out what 7 times 68 is, shall we? 7 times 68. I don't know what 7 eighths are, but I know 7 squared is 49. 7 sevens are 49, plus 1 will make it 50, and then 6 more will make it 56. So that's a 6 and a 5. 7, 6 are 42. 42 plus 5 is 47, I believe. So the total length of all the pieces combined is 476 inches or centimeter or whatever the hell the unit that they're using. Let's simplify this thing, enough of the talk. So here, and then now we know L is this part right here. So I'm going to put it here. So this is 3 S's plus 84 times 3. Let's find out what 84 times 3 is. 4 3s are 12, carry 1, 24 and 25. Which makes perfect sense because 88 times 3 is 24, that will make it 240. And then this is not 80, this is 84, so we got 3 4s, which makes it 12. 240 plus 12 is 252. Voila. 252. So that takes care of that part right here. This takes care of this part. And then we have the L. Then we have L, which is, I think we should line them up properly so that we can actually see it. So this part is 3s's plus 84 times 3, which is found out, is 252, plus L, which we know is 4s plus 14. And that should equal 476 right here. 476. As you can see, this is a very simple, straightforward linear equations. We're going to do it out if you insist, but it's very straightforward. We're done with all of this thing. 3s's plus 4s's is 7s's, must equal 476 minus 252 minus the 14. Let's find out. 476 minus 252 is 422 minus the 14. Oh, that makes it very easy. 210. We can easily divide that by 7. 210. So therefore S equals 210 times, divided by 7 rather, which is 30. Now the question is not asking us the length of the shortest piece, is it? I think they are looking for the length of the longest piece. What is the maximum? Yes, what is the maximum possible length of the longest piece? Let's find out. Right there. Longest piece would be 4 times S, which is 30, plus a 14. 4 times 30 is 120. 120 plus 14 would make it 144. 144 inches. And that would be answer. It's not there. Did I make a mistake in my addition? 4 times 30 is 120, 120, 130, 134, not 44. 134. That's our answer. That's it, that's our answer. The longest piece is 134 inches long. This was an interesting question. Some questions that they give you are too simple and too childish, and some actually are fun to play with. I will see you tomorrow, okay? Bye now.